So we need to solve x cubed minus 1 equals 0 in the form r cos theta, r brackets cos theta plus I sine theta, and display on an Argand diagram. Here's our Argand diagram. Here we've got x cubed, so let f of x equal x cubed minus 1, then polynomial, and we can see that the root is, so f1 equals 1 cubed minus 1, which is 0. So x minus 1 is a factor then by the factor theorem, isn't it? So we need to divide x minus 1 into x cubed minus 1. It goes in, dominant powers goes in x squared, doesn't it? Now multiply through, we get x cubed minus the x squared when we multiply through and subtract. Here we just get nothing minus an x. The x squared, x cubed cancels. The x squared, so there's none here. Take away a minus x squared, we get an x squared. Minus 1, take nothing is minus 1. How many x's go into x squared is plus x. So let's put down x times x is x squared. And then x times minus 1 is minus x. Take them away. The x squareds cancel. Nothing, no x's, take away minus x is x. And minus 1, take nothing is minus 1. How many times does this go into this? Well, we can see it's just 1. So we can see it's x squared plus x plus 1. So that's good then. So now without further ado, let's get rid of this, because we found out the factor, haven't we? So here, x cubed minus 1 is equal to x minus 1 times the x squared plus x plus 1. Okay, that's what we did. We just did a quick bit of division to see that. Now we need the roots, so we can write down roots. So, roots are x equals, well, this value here, when this equals 0, the roots are 1, and also the roots are the solution of this quadratic, so it's minus b plus or minus the square root of all over 2 lots of a, which is 2. Now what's b squared minus 4ac is 1 minus 4 times 1 times 1. So it's 1 minus 4, which is minus 3. So root 3, and we can put an I outside the square root as root minus 1. So there's the roots then that we've got. So here, so this first value then is 1. So let's put that in now. So I'm going to just mark that off here. I'm going to draw in that value there, 1, and mark that off as Z1. So Z1 then, 1, which equals, now the radius is 1, cosine of the angle theta is 0, plus I sine of 0. Agreed? So that's what we've got. So there's r brackets cos theta plus I sine theta, which we've done, and we've marked it off here on the diagram. Z2. So let's turn our attention to this part of the problem now, and go back up in a moment. Equals minus 1 plus root 3 over 2 I is equal to minus a half plus root 3i over 2, which equals, now if we mark that off, it's going to be minus a half plus, it's going to be in this quadrant up here. Agreed? So I'm going to mark it off on the diagram as well. So what have we got then? So let's go from the center, which is here, and it's minus a half plus root 3 over 2, something like that, isn't it? Agreed? It's going to look like that. So there's the point there, and this is Z2. So we've got, here we've got a half, and this side of the triangle we've got root 3 over 2 in our mind's eye. Okay, so there's our triangle. If we drop down the vertical there and go across there. Okay, good. So what have we got then? This distance is this squared plus this squared. This squared is 3/4. This distance is a quarter. A quarter and 3/4 is 1. So I've squared that and got 3/4. So I've squared that and got a quarter, and I've added them and I've got 1. Take the square root, you get 1. So r is 1. And then the angle. This is the angle here. Theta 2. Now what angle is this? Well, the tan of alpha here, alpha 2, is 60. Root 3 over 1, because the 2's cancel, is 60. So this is 120 degrees, or 2 pi over 3. Just by inspection there, just worked it out. So it's r cos 2 pi over 3 radians plus I sine 2 pi over 3 radians. Now let's look at Z3. It's minus 1 minus root 3 I over 2. Okay, so that's equal to minus a half minus root 3 over 2I. So basically, let's draw that in now. So we're going to come down from the center, and we're going to go back minus a half, and then instead of going up, we're going to go down the same amount to about there, isn't it? And now we can mark it in. So this distance here, again, is root 3 over 2. And this distance is a half. So there's symmetry here. So instead of going around 2 pi over 3, we're going to go round to here, and theta 3 is equal to minus 2 pi over 3, isn't it? So that came almost for free there. So here, the distance again is 1. So we've got equal to 1, and it's cosine minus 2 pi over 3 plus I sine of minus 2 pi over 3.